According to the 2020 National Electrical Code, the maximum allowable pull distance for conductors in PVC conduit is based on the conduit fill ratio. For 3/0 THHN/THWN conductors and 1-inch PVC conduit, the NEC allows a fill ratio of 53%. This corresponds to a maximum pull distance of 151 feet for a single 3/0 conductor and 106 feet for 3/0 conductors. However, these distances are based on straight conduits. When dealing with winding conduits, the pull distance must be reduced to account for increased friction. The degree of bend in the conduit will significantly impact the pull force required. The NEC does not provide specific guidance on bend radius for winding paths, but the following guidelines are generally followed. For 90-degree bends, use a minimum bend radius of 6 inches. For gradual bends, use a minimum bend radius of 10 times the conduit diameter, in this case, 1 inch. For winding paths with multiple gradual bends, the pull distance should be reduced by a factor of approximately 2 to 3 times compared to a straight pull. This means that for a 1600-foot run with winding conduits, a pull distance limit of 536 feet to 1072 feet should be considered. Based on the information provided, the following recommendations are suggested. Firstly, pull the conductors in stages, with each stage being less than the calculated pull distance limit. Secondly, use a pulling lubricant to reduce friction. Thirdly, consider using a fish tape or wire guide to help navigate the winding conduits. Fourthly, if possible, install junction boxes or handholds along the conduit path to provide access for additional pulling or maintenance if needed. These recommendations are general guidelines, and the actual pull distance limit may vary depending on specific job conditions and the type of pulling equipment used. It is always advisable to consult with the manufacturer's specifications and follow industry best practices. When calculating wire pull distance in conduit, several factors must be taken into account to prevent damage to the conductors and ensure a successful installation. The type and size of the conduit, the number and size of the conductors, the bend radius and number of bends, and the presence of any pulling lubricant all play a significant role in determining the maximum pull distance. Firstly, the type and size of conduit influence the allowable fill ratio and friction. PVC conduit, for example, has a smoother interior surface compared to rigid metal conduit, resulting in lower friction. The inside diameter of the conduit determines the available space for the conductors, which is governed by the NEC fill requirements. Overfilling the conduit can lead to increased friction and make pulling the wires more difficult, potentially damaging the insulation. Secondly, the number and size of conductors directly affect the pulling force required. As the number and size of conductors increase, the total cross-sectional area of the conductors within the conduit also increases, leading to higher friction. The NEC specifies maximum fill percentages for different conduit types and conductor combinations, which must be adhered to. These fill percentages are based on the cross-sectional area of the conductors relative to the internal area of the conduit. Thirdly, the bend radius and number of bends significantly impact the pulling force. Each bend in the conduit introduces additional friction, increasing the overall force needed to pull the wires. Sharp bends with small radii create more friction than gradual bends with larger radii. The NEC provides guidelines for minimum bend radii to prevent damage to the conductors during pulling. The total number of bends in a conduit run is also limited by the NEC to minimize the cumulative effect of friction. Fourthly, the use of pulling lubricant is essential for reducing friction between the conductors and the conduit. Pulling lubricants are specifically designed to lower the coefficient of friction, making it easier to pull wires through long or complex conduit runs. The type of lubricant used should be compatible with the conductor insulation and the conduit material. Applying lubricant evenly and liberally along the conductors before pulling can significantly reduce the required pulling force. In addition to these factors, the pulling method and equipment used can also affect the maximum pull distance. Manual pulling with ropes or fish tapes is suitable for shorter runs with fewer bends, while power pulling equipment is recommended for longer runs or those with multiple bends. Power pulling equipment provides more consistent and controlled pulling force, reducing the risk of damage to the conductors. To accurately calculate the maximum pull distance, various methods and formulas are available. The most common method involves using a pulling force calculator or software that takes into account the factors mentioned above. These tools typically require inputting the conduit type and size, the number and size of conductors, the bend radius and number of bends, and the type of pulling lubricant used. The calculator then estimates the pulling force required and compares it to the allowable pulling force for the conductors and conduit. Another method involves using the NEC guidelines for conduit fill and bend limitations. The NEC provides tables and formulas for calculating the maximum number of conductors allowed in different conduit sizes and the minimum bend radii for different conductor sizes. By adhering to these guidelines, the risk of overstressing the conductors during pulling can be minimized. In practice, it is often necessary to break long conduit runs into shorter segments by installing pull boxes or junction boxes along the way. Pull boxes provide access points for pulling wires, allowing the run to be divided into manageable sections. The placement of pull boxes should be strategically planned to minimize the pulling force required and to avoid exceeding the maximum pull distance. When installing pull boxes, it is important to ensure that they are properly sized to accommodate the conductors and that they are accessible for future maintenance. Furthermore, proper installation techniques are crucial for ensuring a successful wire pull. The conduit should be securely supported and aligned to prevent sagging or misalignment, which can increase friction. The conductors should be carefully fed into the conduit to avoid twisting or kinking, which can also increase friction and potentially damage the insulation. The pulling force should be applied gradually and steadily to avoid sudden jerks or strains, which can overstress the conductors. After the wires have been pulled, they should be inspected for any signs of damage, such as cuts, abrasions, or deformations. Any damaged conductors should be replaced before energizing the circuit. Finally, it is important to document the conduit run and the wire pulling process. This documentation should include the conduit type and size, the number and size of conductors, the bend radius and number of bends, the type of pull and lubricant used, the location of pull boxes, and any other relevant information. This documentation can be helpful for future maintenance or troubleshooting. In addition to the guidelines provided in the NEC, various industry standards and best practices offer further guidance on wire pulling. Organizations such as the National Electrical Contractors Association and the Insulated Cable Engineers Association publish standards and recommended practices for wire pulling, covering topics such as conduit preparation, lubricant selection, pulling force calculation, and installation techniques. Adhering to these standards and best practices can help ensure a safe and successful wire pull. It is also important to consider the specific requirements of the local electrical codes and regulations. Local codes may have additional requirements or restrictions on wire pulling, such as limitations on the maximum pull distance or the use of specific types of pulling equipment. It is the responsibility of the installer to be familiar with and comply with all applicable codes and regulations. In summary, calculating wire pull distance and conduit requires careful consideration of several factors, including the conduit type and size, the number and size of conductors, the bend radius and number of bends, and the use of pulling lubricant. By following the guidelines provided in the NEC industry standards and local codes, and by using proper installation techniques, the risk of damage to the conductors and the potential for failed installation can be minimized. When pulling 3/0 THHN/THWN wire through PVC conduit, understanding the limitations and best practices is crucial for a safe and efficient installation. Firstly, let's define the terms. 3/0 refers to the American wire gauge size of the conductor. THHN/THWN indicates the insulation type, with THHN standing for thermoplastic high heat resistant nylon coated, and THWN standing for thermoplastic heat and water resistant nylon coated. PVC stands for polyvinyl chloride, a common type of electrical conduit. The National Electrical Code, or NEC, sets the standards for electrical installations in the United States. Chapter 9 of the NEC provides tables and guidelines for conduit fill, conductor properties, and ampacity. Article 300 covers general wiring methods, including requirements for conduit installation. Article 310 addresses conductors for general wiring, including ampacity ratings and installation requirements. When pulling wire through conduit, friction is a major concern. Friction arises from the contact between the wire insulation and the inner surface of the conduit, as well as from bends and changes in direction. The amount of friction depends on several factors, including the type of conduit, the type of wire insulation, the number of wires in the conduit, and the presence of pulling lubricant. Exceeding the maximum pulling force can damage the wire insulation, leading to shorts, ground faults, and potential safety hazards. The NEC specifies maximum conduit fill percentages to prevent overheating and ensure adequate space for heat dissipation. For 3 or more conductors in a conduit, the maximum fill percentage is typically 40%. This means that the total cross-sectional area of the conductors cannot exceed 40% of the internal cross-sectional area of the conduit. To calculate the conduit fill, you need to know the dimensions of the 3/0 THHN/THWN wire and the internal diameter of the PVC conduit. The wire dimensions can be found in Chapter 9, Table 5 of the NEC. For 3/0 THHN/THWN, the approximate diameter is 0.531 inches. The cross-sectional area of the wire can be calculated using the formula for the area of a circle, which is pi times the radius squared. The internal diameter of the PVC conduit depends on the trade size. For example, 1-inch PVC conduit has an internal diameter of approximately 1.49 inches. Using these values, you can calculate the conduit fill percentage and determine if the installation complies with the NEC requirements. In addition to conduit fill, bends also contribute to friction. Each bend in the conduit increases the pulling force required. The NEC specifies minimum bending radii for different conduit sizes to prevent damage to the wires. The minimum bending radius for PVC conduit is typically 5 times the trade diameter of the conduit. For example, 1-inch PVC conduit must have a minimum bending radius of 5 inches. The number of bends in a conduit run is also limited by the NEC. There should not be more than the equivalent of 4 90-degree bends, or 360 degrees total, between pull points such as pull boxes, junction boxes, or conduit bodies. Pulling lubricant is essential for reducing friction and making the wire pulling process easier. Use a lubricant specifically designed for electrical wire pulling. Apply the lubricant liberally to the wires before inserting them into the conduit. Avoid using excessive force when pulling the wires. Use a steady, continuous pulling motion to minimize friction and prevent damage to the insulation. If the pulling force becomes too high, stop and relubricate the wires or consider using a larger conduit size. For long conduit runs, it may be necessary to install pull boxes or junction boxes at intermediate points. These boxes provide access to the wires, allowing you to break the run into shorter segments and reduce the pulling force required. The NEC specifies the maximum spacing between pull boxes, which depends on the size of the conduit and the number of bends in the run. When selecting pull boxes, choose boxes that are large enough to accommodate the wires and allow for easy access. Consider using conduit bodies, such as LB fittings, to make bends in the conduit run. Conduit bodies provide a smoother pathway for the wires, reducing friction and making the pull easier. When installing conduit bodies, ensure that they are properly supported and aligned. Use appropriate fittings and connectors to join the conduit sections. Ensure that the fittings are properly tightened to prevent moisture from entering the conduit. When working with electrical systems, always follow safe work practices. To energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or refer to the NEC for specific requirements and recommendations. Always refer to the latest edition of the NEC and any applicable local codes for specific requirements and regulations. When calculating voltage drop, remember that it increases with the length of the conductor and the amount of current flowing through it. The formula for voltage drop is voltage drop equals current times resistance. The resistance of the conductor depends on its material, length, and cross-sectional area. To minimize voltage drop, use larger conductors or reduce the length of the circuit. The NEC provides guidelines for voltage drop in branch circuits and feeders. The recommended maximum voltage drop is 3% for branch circuits and 5% for feeders. When selecting overcurrent protection devices, such as circuit breakers and fuses, choose devices that are properly sized to protect the conductors and equipment. The overcurrent protection device should have an ampacity rating that is equal to or less than the ampacity of the conductor it is protecting. The NEC provides tables for determining the ampacity of conductors based on their size, insulation type, and installation conditions. When installing grounding and bonding systems, follow the requirements in Article 250 of the NEC. Grounding and bonding systems provide a low impedance path for fault current, helping to protect people and equipment from electrical shock. Ensure that all metal enclosures, such as conduit, boxes, and equipment cabinets, are properly grounded and bonded. When working with PVC conduit, use appropriate tools and techniques. PVC conduit can be cut with a saw or a special PVC cutter. Deburr the cut ends of the conduit to prevent damage to the wires. Use PVC cement to join the conduit sections. Ensure that the cement is properly applied and that the joint is allowed to cure fully. Support the conduit properly to prevent sagging and ensure that it is securely fastened to the building structure. When pulling wires through underground conduit, take precautions to protect the wires from moisture and physical damage. Use waterproof connectors and fittings to prevent water from entering the conduit. Backfill the trench with suitable material to protect the conduit from damage. Mark the location of the underground conduit to prevent accidental digging or excavation. Regularly inspect the electrical system for any signs of damage or deterioration. Check for loose connections, corroded terminals, and damaged insulation. Repair any problems promptly to prevent electrical hazards. Keep the electrical panel clean and free from obstructions. Label the circuit breakers clearly to identify the circuits they protect. Store flammable materials away from the electrical panel. Educate yourself about electrical safety and best practices. Attend training courses and seminars to stay up to date on the latest electrical codes and technologies. Read trade publications and websites to learn about new products and techniques. Share your knowledge with others to promote electrical safety in the workplace and at home. Remember that electrical work can be dangerous, so always take precautions to protect yourself and others. If you are unsure about any aspect of the electrical system, consult with a qualified electrician. In conclusion, successfully pulling 3/0 THHN/THWN wire through PVC conduit requires a thorough understanding of the NEC requirements, proper planning, and careful execution. By following the guidelines and best practices outlined above, you can ensure a safe and efficient installation that meets the highest standards of quality and reliability. The successful installation of electrical wiring, particularly when dealing with long runs and winding conduits, necessitates a comprehensive understanding of electrical codes, material properties, and practical techniques. When confronted with a project that involves pulling 3/0 THHN/THWN conductors through PVC conduit over a distance of 1,600 feet with numerous bends, a systematic approach is essential to mitigate potential challenges and ensure a safe and compliant installation. Firstly, meticulous planning is paramount. Before commencing any physical work, a thorough assessment of the conduit route is necessary. This involves identifying the number and severity of bends, evaluating potential obstructions, and determining the most efficient path for the conduit run. A detailed plan should outline the location of pull boxes or junction boxes, the type and size of conduit to be used, and the sequence of installation. Secondly, selecting the appropriate materials is crucial. 3/0 THHN/THWN conductors are commonly used for power distribution due to their high ampacity and heat resistance. PVC conduit is a versatile and cost-effective option for protecting electrical wiring, particularly in underground or corrosive environments. However, it is essential to ensure that the conduit is properly sized to accommodate the conductors and that all fittings and connectors are compatible with the conduit material. Thirdly, understanding the National Electrical Code is indispensable. The NEC provides comprehensive guidelines for electrical installations, including requirements for conduit fill, conductor ampacity, and bending radii. Adhering to these guidelines is not only essential for safety but also for ensuring compliance with local regulations. The NEC specifies the maximum number of conductors allowed in a conduit based on the conduit size and conductor type. It also sets limits on the number of bends allowed in a conduit run between pull points. Fourthly, employing proper installation techniques is critical. This includes using appropriate tools for cutting, bending, and joining the conduit sections. PVC conduit can be easily cut with a saw or a specialized PVC cutter. Bending can be accomplished using a heat blanket or a conduit bender. Joints should be made using PVC cement, ensuring that the surfaces are clean and dry before applying the cement. Fifthly, minimizing friction is essential for successful wire pulling. Friction is the primary obstacle to overcome when pulling wires through long conduit runs. To reduce friction, several techniques can be employed. Using a pulling lubricant specifically designed for electrical wiring is highly recommended. These lubricants reduce the coefficient of friction between the conductors and the conduit, making it easier to pull the wires. Another technique is to use a wire pulling machine, which provides a controlled and consistent pulling force. Wire pulling machines can significantly reduce the amount of physical effort required and minimize the risk of damaging the conductors. Sixthly, strategically placing pull boxes is crucial. Pull boxes serve as access points for pulling wires, allowing the conduit run to be divided into shorter segments. The NEC specifies the maximum spacing between pull boxes based on the conduit size and the number of bends in the run. Pull boxes should be located in accessible locations and should be sized appropriately to accommodate the conductors and allow for easy access. Seventhly, implementing a staged pulling approach is advisable. For long conduit runs, it may be necessary to pull the wires in stages. This involves pulling a pilot wire through the entire conduit run and then using the pilot wire to pull the conductors in sections. This approach reduces the amount of pulling force required at any one time and minimizes the risk of damaging the conductors. Eighthly, conducting thorough inspections is essential. After the wires have been pulled, a thorough inspection should be conducted to ensure that the conductors are properly installed and that there are no signs of damage. The insulation should be checked for cuts, abrasions, or other defects. The connections at the termination point should be inspected to ensure that they are tight and secure. Ninthly, documenting the installation is crucial. A detailed record of the installation should be maintained, including the conduit route, the type and size of conduit used, the number of conductors, the location of pull boxes, and any other relevant information. This documentation can be invaluable for future maintenance or troubleshooting. Tenthly, prioritizing safety is paramount. Electrical work can be hazardous, and it is essential to take all necessary precautions to protect yourself and others. Always de-energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician. When stepping up the voltage from 240 volts to 480 volts and then back down, transformers are required. Transformers are electrical devices that transfer energy from one circuit to another through electromagnetic induction. The voltage ratio of a transformer is determined by the ratio of the number of turns in the primary winding to the number of turns in the secondary winding. When stepping up the voltage, a step-up transformer is used, which has more turns in the secondary winding than in the primary winding. When stepping down the voltage, a step-down transformer is used, which has fewer turns in the secondary winding than in the primary winding. The choice of transformer depends on the specific voltage requirements of the application. It is essential to ensure that the transformers are properly sized to handle the load and that they are installed in accordance with the NEC requirements. In addition to the technical aspects of the installation, it is also important to consider the environmental conditions. If the conduit is exposed to sunlight, it should be protected from ultraviolet radiation, which can degrade the PVC material over time. This can be accomplished by using a UV-resistant conduit or by painting the conduit with a UV-resistant coating. If the conduit is located in a wet or corrosive environment, it should be protected from moisture and corrosion. This can be accomplished by using waterproof fittings and connectors and by applying a protective coating to the conduit. By following these guidelines, you can ensure a safe, compliant, and reliable electrical installation.